Way back in Gen Chem 1, we learned about protons, neutrons, and electrons. And we learned how to look at a periodic table to be able to tell how many of each of these there were in an atom. And so, for example, boron, if I look at him, in fact, let's see if I can can't do this on a chalkboard. If I look at boron, all right, what this symbol means, usually somewhere along the top is a number. Sometimes it's on the left, sometimes it's right, sometimes it's on the center. This is boron's atomic number. And this is his number of protons. And no other element only has 5 protons. Boron is the only one that has exactly 5 protons. And if I look back at the periodic table, this is arranged by atomic number. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. That's the atomic number. That's the number of protons. If I look down here, and again, this is usually at the bottom of that symbol, this is not the mass number. This is the atomic mass. And it is an average of all the isotopes. And not only an average, but it is a weighted average. Some isotopes of boron are much more common than others, and so all the various isotopes are weighted by their natural abundance, and that is the weighted average of all the isotopes of boron. Since it rounds to 11, it's very close to 11, it might be safe to assume that the most common mass number of boron is 11, and a mass number is a whole number because it represents the number of protons plus the number of neutrons. So if the mass number, if I'm looking at boron, which has a mass number of 11, now when we go to this symbol, the position of the mass number and the atomic number are flipped. Don't ask me why, it just is. It is common to see the symbol for boron like this, with the 11 in the upper left-hand corner, which stands for the mass number, the 5 in the bottom left corner, which stands for the atomic number, which means this boron has 5 protons because he's boron. That is his unique atomic number. And since his mass number is 11, and that is the protons plus the neutrons, he must have 6 neutrons. 6 plus 5 is 11. So I can tell if I see the symbol, if I see a symbol in this format, I can tell how many protons and neutrons there are. We also learned about electrons. Electrons are very important for chemical reactions, as we've been seeing in the last several modules, the electrochemistry module especially, the acid-base module. Those charges in the upper right-hand corner tell you how many electrons there are. We're not worried about electrons as we move into nuclear chemistry. As we move into nuclear chemistry, we're only concerned with what is happening, can't talk it right, in the nucleus, and that's the protons and the neutrons. So having said that, now as I look at any of these symbols then, I can tell protons, that's the atomic number, that's how many protons. I can't tell mass number from the periodic table because it could vary. The mass number, there might be several different mass numbers for a particular atom, which are the different isotopes. But if I see the symbol written in this fashion, I know what the mass number is because it's listed right there in the upper left. In a nuclear chemistry reaction, we are concerned with which isotope we're talking about. We never were with chemical reactions. We never wrote numbers. After we did this module in Gen Chem 1, which is usually module 1 or 2, very early on, we never talked about it again because it wasn't important for chemical reactions, but it is important for nuclear reactions.